In the 1980s, the United States became acutely aware of its reliance on fossil fuels. The second oil crisis was a rude awakening to the failure of America's energy policy.
3, 2, 1.
A small group of scientists looked to space as a prospective solution for the world's energy needs.
And liftoff of the Falcon 9 rocket and Dragon.
Hi, I'm Corey Bergsrud. I'm a doctoral student studying electrical engineering at the University of North Dakota. I'm working to ensure that the United States and the world will have energy to meet its future needs.
I'm Ben Cady, the lead mechanical design engineer for the Low Earth Orbit Space Solar Power Test mission. We've designed 2 small spacecraft that we plan to launch to demonstrate how power can be safely transferred in space.
By showing that power can be transferred from one spacecraft to another using invisible microwave beams, like the kind used to heat your food, we're advancing the technology to augment the world's electric grid with gigawatts of additional power. Power the world will desperately need.
Our spacecraft will catch a ride with a much larger government satellite in the low Earth orbit. Once this primary satellite has been deployed, our small satellite will be launched and begin its own mission.
Our satellite will split into 2 pieces. A small CubeSat will be launched to a distance of approximately 25 meters away. After running some quick checks, both will deploy their power transmission hardware. The transmitting craft will also deploy its solar array.
On board the receiving craft, we'll measure how much power is received and available for use. From this, we can determine the efficiency of the overall system. This data will help us to build public confidence in the microwave power transfer technology. This technology will be used in space and from space to Earth. In the future, with a space power network deployed, satellites can recharge by flying through the microwave beam as simply as a car going to the gas station.
The project involves faculty and students from 4 departments and 2 colleges. They're collaborating to design and develop small spacecraft, but they're also producing much more.
As a freshman, I never imagined I would have the opportunity to be designing a spacecraft. I'm working with well-known companies like the United Launch Alliance and Boeing. Not only am I learning about spacecraft development, I'm also learning professional communication skills.
As an international student from Nepal, I was drawn to this project due to my home country energy concerns. For this design competition, I have been working to develop and analyze the thermal control system of the spacecraft to make sure that it works reliably in low Earth orbit.
I'm excited to work with this group of diverse people. As project lead, I'm able to draw upon their considerable expertise to make my dream of a space solar power utility a reality.
As a recent graduate with a degree in electrical engineering, this project is enabling me to demonstrate the skills I've learned at the university. I worked on the integration of electrical subsystems and gained valuable experience in systems level thinking.
While students are gaining valuable experience in building their entrepreneurial spirit, the project extends far beyond the classroom.
This part's stationary.
When you build a small spacecraft, you're learning about lots of discrete subsystems, but you're also learning how to make all of the parts work together. It's a little bit systems engineering, a little bit project management, and a lot of just doing whatever the project needs. People are going from building a CubeSat or other small spacecraft to industry or government, and they're challenging the conventional thinking. They're asking, why does it have to be done this way? And they're speaking from experience.
I'm excited to be involved. The next few decades will change the way humanity gets and uses energy.
I'm looking to bring this idea to the areas of the world where it's most needed.
I'm excited to get started in the space industry.
I'm really excited about the technology and its applications.
Work on space solar power is ongoing at the University of North Dakota. We're training the next generation of space professionals and building the technologies to enable tomorrow's space missions and power life on Earth.